It started as nothing more than a faint glimmer against the cosmic darkness. Now, the James Webb Space Telescope has captured the first detailed image of 3I/Atlas, revealing secrets that challenge everything we thought we knew about visitors from beyond our solar system. What they discovered will change astronomy forever. The flicker in the dark. What began as a subtle anomaly in astronomical data has evolved into one of the most significant discoveries in modern space science. On July 1, 2025, the Atlas telescope in Rio Hurtado, Chile, first detected a mysterious object designated A11PL3Z, initially appearing as nothing more than a faint magnitude 18 point of light moving through the border regions of constellations Serpens Cauda and Sagittarius. Global observatories immediately mobilized, with facilities worldwide turning their instruments toward this enigmatic visitor. The object's unusual motion patterns quickly attracted attention from professional and amateur astronomers alike, sparking an unprecedented international collaboration. Within hours of detection, follow-up observations from the Canada-France-Hawaii Telescope and Lowell Discovery Telescope revealed something extraordinary. This wasn't just another asteroid or comet drifting through our cosmic neighborhood. The discovery observations were rapidly submitted to the International Astronomical Union's Minor Planet Center, but what astronomers found defied conventional expectations. This sudden appearance in our telescopic view marked the beginning of a collective quest to understand what would soon be recognized as humanity's third confirmed interstellar visitor, forever changing our understanding of cosmic wanderers. Beyond the solar veil. How do astronomers definitively prove that an object originated from the vast emptiness between stars? The answer lies in 3I/Atlas's extraordinary orbital characteristics that firmly establish its interstellar origins. Follow-up observations quickly confirmed this wasn't an ordinary solar system resident but a genuine visitor from beyond our cosmic borders. The object follows an extremely hyperbolic trajectory with an orbital eccentricity of 6.141, the highest ever recorded for any confirmed interstellar object. Racing through space at an incredible 58 kilometers per second relative to our Sun, 3I/Atlas moves significantly faster than the previous record holders, 1I/Oumuamua at 26 kilometers per second and 2I/Borisov at 32 kilometers per second. Its trajectory appears almost perfectly straight rather than curved, a telltale signature of an unbound hyperbolic orbit that will carry it back into the depths of interstellar space forever. Researchers worldwide marveled at calculations showing this cosmic wanderer had journeyed across the galaxy for potentially billions of years before entering our solar system. The realization that 3I/Atlas represents authentic material from another star system, possibly formed around a star that died before our Sun was born, has sent shockwaves through the astronomical community and fundamentally expanded our understanding of galactic wanderers. The accelerating mystery. Why does 3I/Atlas exhibit velocity patterns that challenge our understanding of gravitational mechanics? Scientists conducting detailed trajectory analysis discovered that this interstellar visitor displays acceleration characteristics unlike typical comets or asteroids bound to our solar system. While most celestial objects follow predictable paths determined purely by gravitational influences from the Sun and planets, 3I/Atlas demonstrates subtle but measurable deviations from expected trajectories. These anomalous acceleration patterns suggest forces beyond simple gravitational attraction are influencing its motion through space. The object's behavior resembles that of 1I/Oumuamua, which famously displayed mysterious non-gravitational acceleration that baffled scientists and sparked controversial theories about possible artificial origins. Early observations showed 3I/Atlas beginning cometary activity, while still 4.5 astronomical units from the Sun, much farther than typical solar system comets start outgassing. This early activation, combined with its unusual velocity profile, creates an accelerating mystery that challenges conventional models of cometary physics. The combination of extreme speed, hyperbolic trajectory, and anomalous acceleration has forced astronomers to reconsider fundamental assumptions about how interstellar objects behave when passing through foreign star systems, opening new avenues of research into the complex dynamics of cosmic wanderers. Patterns in the void. What does the increasing frequency of interstellar discoveries reveal about our galaxy's hidden population of cosmic wanderers? The detection pattern of interstellar objects has shifted dramatically from theoretical possibility to observable reality in just 8 years. Following the groundbreaking discovery of 1I Oumuamua in October 2017 and 2I Borisov in August 2019, the arrival of 3I Atlas in July 2025 suggests these cosmic travelers are far more common than previously imagined by theoretical models. Statistical analysis indicates that millions of such objects likely pass through the outer solar system undetected each year, with only recent technological advances allowing regular detection of these elusive visitors. The Atlas Survey Network and similar sky monitoring systems have finally reached the sensitivity threshold necessary to spot interstellar objects during their brief passages through our cosmic neighborhood. Each discovery has revealed unique characteristics. Oumuamua appeared asteroid-like with mysterious acceleration. Borisov behaved like a typical comet with visible tail and coma, while 3I Atlas combines cometary features with unprecedented size and ancient age. This evolving pattern challenges previous galactic models that suggested interstellar objects should be extremely rare, instead revealing a galaxy filled with wandering worlds ejected from distant planetary systems. The rapid succession of discoveries implies we've entered a new era, where studying visitors from other star systems will become routine rather than extraordinary, fundamentally transforming our understanding of galactic dynamics. The machine hypothesis. Could the James Webb Space Telescope's unprecedented imaging capabilities reveal evidence that 3I Atlas represents advanced technology rather than natural formation? The Space Telescope's revolutionary infrared sensors and massive mirror have captured details of this interstellar visitor that were impossible to obtain with previous instruments. Webb's thermal imaging reveals surface features and material compositions that challenge conventional explanations for natural comet formation. The object's reflective patterns across multiple wavelengths show uniformity inconsistent with typical rocky or icy compositions, suggesting potentially engineered characteristics. Most intriguingly, Webb's sensitive instruments detected structured electromagnetic emissions from 3I Atlas that don't match expected signatures from sublimating ice or outgassing dust. These artificial characteristics have rekindled the machine hypothesis first proposed by Professor Avi Loeb of Harvard University, who previously suggested that Oumuamua might represent extraterrestrial technology. Loeb argues that 3I Atlas's statistically impossible trajectory through our solar system, combined with its extreme age and unusual properties, suggests possible artificial construction designed for reconnaissance purposes. The telescope's observations reveal thermal properties that appear too stable and controlled for natural processes, hinting at sophisticated materials or construction methods. While most astronomers favor natural explanations, Webb's data continues to fuel ongoing debate about whether humanity has encountered its first confirmed example of extraterrestrial engineering, making 3I Atlas potentially the most significant discovery in human history. Spectral secrets. What hidden information lies encoded in the light signatures captured by humanity's most advanced space telescopes? Advanced spectroscopic analysis by both the James Webb Space Telescope and Hubble Space Telescope has revealed electromagnetic signatures from 3I Atlas that fundamentally challenge our understanding of interstellar object composition. Webb's near-infrared spectroscopy detected water ice, hydroxide ions, and silicate minerals within the object's coma, but also identified spectral features that don't correspond to any known natural materials. The reflectance spectrum shows a complex reddish coloration with specific color indices of G-R equals 0.43 magnitudes and R-I equals 0.16 magnitudes, similar to D-type asteroids but with anomalous absorption lines that suggest exotic chemical compositions. Most puzzling are the electromagnetic fluctuations detected across multiple wavelengths that appear too structured and regular to result from random sublimation processes. Hubble's ultraviolet observations on July 21, 2025, captured unexpected emission signatures that don't match typical cometary outgassing patterns, hinting at non-natural energy sources or material properties. The spectral slope of 1.3% per 100 nanometers indicates surface materials altered by cosmic radiation, yet the object maintains structural integrity, despite its estimated age of over 7 billion years. These spectral secrets invite fundamental reconsideration of how we interpret astronomical data, pushing the boundaries between natural phenomena and potentially engineered materials that could represent technology from advanced civilizations. The information blackout. Why have government agencies suddenly imposed unprecedented restrictions on data sharing regarding 3I/Atlas observations? Despite intense international scientific interest and the collaborative nature of astronomical research, multiple government entities have quietly implemented strict controls over information access surrounding this interstellar visitor. Research teams at major observatories report facing unusual bureaucratic obstacles when attempting to publish certain findings, with specific datasets being classified under national security provisions typically reserved for military applications. The Pentagon's All-Domain Anomaly Resolution Office has reportedly issued guidance restricting public release of detailed trajectory calculations and compositional analysis data. International collaborations that normally share telescope time and observational data freely have encountered coordination difficulties, with some facilities receiving directives to limit foreign access to 3I/Atlas research. Professional astronomers working on the project describe an atmosphere of unusual secrecy, with peer review processes being delayed and certain papers being withdrawn from publication without explanation. NASA and ESA officials have declined to comment on specific restrictions, citing ongoing analysis and security considerations. This information blackout represents a dramatic departure from the open scientific collaboration that characterized previous interstellar object discoveries, fueling speculation about what potentially explosive discoveries might be hidden from public view. The veil of secrecy surrounding 3I/Atlas creates unprecedented tension between scientific transparency and government oversight, raising fundamental questions about who controls access to potentially paradigm-shifting cosmic discoveries. Controlled heat and hidden intent. How could a natural object billions of years old exhibit thermal management systems that suggest intelligent design? James Webb Telescope observations have revealed thermal patterns in 3I/Atlas that, honestly, just defy our conventional understanding of how cosmic objects regulate temperature during solar approach. Rather than heating passively as solar radiation intensity increases, the object actually exhibits sophisticated thermal stabilization that maintains structural integrity through controlled energy distribution. Webb's mid-infrared instrument captured thermal emission spectra showing heat dissipation patterns inconsistent with natural sublimation processes, suggesting, adaptive temperature regulation mechanisms. The object's surface maintains remarkably uniform temperatures across different regions, despite varying solar exposure angles indicating possible internal thermal management systems. Most extraordinarily, 3I/Atlas demonstrates selective heating patterns that appear to prioritize structural preservation over random thermal expansion, behavior that really implies intentional engineering rather than just natural physics. Temperature fluctuations follow mathematical patterns rather than the chaotic thermal dynamics you'd expect from cometary outgassing, with heat distribution appearing optimized for maintaining operational stability. Thermal infrared observations reveal controlled heat signatures that could indicate sophisticated material science or advanced construction methods designed to survive billion-year journeys through interstellar space. These controlled thermal characteristics suggest hidden intentions beyond simple cosmic wandering, pointing toward potential reconnaissance or scientific mission parameters that would require long-term operational capability. The prime number message. Could mathematical sequences embedded in thermal fluctuations represent the first confirmed extraterrestrial communication attempt in human history? Advanced computer analysis of Webb telescope thermal data has detected numerical patterns within 3I/Atlas's heat emission cycles that correspond to prime number sequences, with mathematical precision that honestly exceeds statistical probability for random occurrence. The sequences appear encoded in temperature fluctuation intervals, following the mathematical progression across multiple observational periods. These prime number patterns emerge from thermal data with statistical significance that, really, rules out coincidental natural processes suggesting deliberate mathematical encoding within the object's thermal behavior. MIT researchers analyzing the data report that the probability of such precise mathematical sequences occurring naturally approaches zero, indicating intentional information encoding. The prime number sequences repeat in cycles corresponding to the object's 16.79-hour rotation period, suggesting systematic transmission rather than random thermal variation. Additional mathematical analysis has identified Fibonacci sequences and other mathematical constants embedded within the thermal signature patterns, implying sophisticated understanding of mathematical concepts that would indicate intelligent origin. The discovery that 3I Atlas appears to be actively transmitting mathematical information through thermal modulation represents a potential paradigm shift in human understanding of extraterrestrial intelligence and communication methods. If confirmed, these prime number messages would constitute the first verified example of interstellar communication, fundamentally changing humanity's cosmic perspective and confirming that we are not alone in the universe through the universal language of mathematics. The Watchers and the Watched. How has the arrival of 3I Atlas fundamentally transformed humanity's understanding of our cosmic significance and role in the galaxy? The implications of this interstellar visitor extend far beyond simple astronomical discovery, forcing a complete inversion of humanity's traditional perspective on extraterrestrial contact and cosmic observation. For centuries, humans have positioned ourselves as the observers, scanning the skies, searching for signs of life, and assuming we were the cosmic detectives investigating an empty universe. The potential artificial nature of 3I Atlas, combined with its apparent mathematical communication attempts, suggests that we have been the subjects of observation rather than the observers. This revelation that advanced civilizations might have been monitoring Earth for thousands of years fundamentally challenges anthropocentric assumptions about human uniqueness and cosmic importance. The object's trajectory through our solar system, timed with humanity's technological advancement and space exploration capabilities, suggests deliberate reconnaissance designed to assess our civilizational development. Professor Avi Loeb theorizes that 3I Atlas represents evidence of a galactic community that has been studying emerging civilizations like humanity, treating us as subjects in a cosmic anthropological study. The mathematical prime number sequences detected in its thermal emissions could represent attempts at first contact using universal mathematical concepts that any technological civilization would recognize. This paradigmatic shift from watchers to watched forces humanity to reconsider our cosmic role, our readiness for interstellar contact, and the profound implications of discovering that we have been under observation by intelligences far more advanced than our own, fundamentally redefining our place in the cosmic hierarchy. As 3I Atlas continues its journey through our solar system, carrying its mathematical messages and thermal secrets, humanity stands at the threshold of the most profound discovery in our history. The James Webb Telescope has shown us that we are not alone, and perhaps never were. For more groundbreaking space revelations that challenge everything we know about the universe, stay tuned to Space Facts. A Harvard scientist is sounding the alarm. An interstellar visitor, 3I Atlas, is shedding metallic alloys that just shouldn't exist. Real data from our best telescopes shows atomized nickel streaming from its core, but with practically zero iron, a chemical fingerprint that really defies everything we know. Harvard's Avi Loeb is asking the question no one else wants to: if these metals aren't natural, what does that mean? The answer could upend our place in the universe, so let's explore this together. The discovery of 3I Atlas. What would you do if you saw something moving at 130,000 miles per hour that wasn't supposed to be there? On July 1st, 2025, the Atlas survey team in Chile spotted a faint, fast-moving speck. The math instantly told a story that just didn't fit any known playbook. Its path wasn't just a long loop, it was hyperbolic, with an extreme eccentricity that confirmed it was a visitor from deep space, moving too fast for the sun to ever capture it. This wasn't a comet on a return trip. Astronomers combed through archival data and found earlier images, firming up its trajectory. The object was born far beyond our solar system, possibly somewhere near the galactic center. By the time it was discovered, it was already inside Jupiter's orbit, making a one-time slingshot around our sun before it shoots back into the void. Its incredible velocity confirmed it. 3I Atlas is only the third confirmed interstellar object ever seen, a messenger from another star that will never return. This isn't just a rock, it's a clue from an unknown part of the galaxy. The Nickel Mystery. Imagine finding a fingerprint that doesn't match any person on Earth. That's what astronomers found in the light from 3I Atlas. Almost as soon as it crossed Jupiter's orbit, spectrographs detected strong signals of atomic nickel streaming from its coma. But the real shock wasn't what was there, it was what was missing. There was virtually no iron. This isn't just unusual, it's chemically bizarre. In every meteorite and comet we've ever studied, nickel and iron are cosmic partners, forged together in the hearts of dying stars and locked into the same minerals. When a comet heats up, they should be released together. Yet, data from the Very Large Telescope showed nickel vaporizing off the object, while iron was a no-show. Harvard astrophysicist Avi Loeb was the first to publicly highlight how unnatural this is. He argues that separating nickel from iron requires industrial processes here on Earth. In space, it's unheard of. It's like finding a gold ring without any trace of the other metals typically alloyed with it. This single chemical clue is so potent that it forces a profound question. Are we witnessing a freak of nature, or is this a deliberate engineered signature? Carbon dioxide dominance. Just when the nickel-iron problem had scientists scrambling, the James Webb Space Telescope delivered another bombshell. Pointing its powerful infrared instruments at 3I Atlas, a team of astronomers analyzed the gases in its coma, and found that carbon dioxide was completely dominating the mix. The measured carbon dioxide to water ratio was a staggering 8-to-1, the highest ever recorded for any comet, whether from our solar system or beyond. To put that in perspective, typical solar system comets have CO2 levels around 4% of their water content. Here, CO2 is the main ingredient. This wasn't a fluke. The readings remained consistent across multiple observation sessions as the object neared the sun. While other gases like carbon monoxide were present, nothing came close to the CO2 spike. This kind of chemistry just doesn't align with our models of comet formation. Some researchers propose that its unique composition is the result of being cooked by cosmic rays over a billion-year journey. Others wonder if it's a clue to the specific conditions of its home star system. But the question remains, does this unprecedented chemistry point to nature at its most extreme, or is it another sign that something else is at play? The Oumuamua precedent. This isn't the first time an interstellar visitor has broken all the rules. Back in late 2017, astronomers detected one Oumuamua. At first it seemed like an asteroid, but its behavior was deeply strange. As it swung past the sun, it began to accelerate, pushed by a force that wasn't gravity. The problem? There was no visible outgassing, no tail, no coma, none of the typical rocket-like effects a comet uses to speed up. Oumuamua left nothing behind. Its light curve also suggested a bizarre shape, perhaps 10 times longer than it was wide, like a cigar or a flat pancake. The scientific community scrambled for an explanation: exotic ices, hydrogen outgassing, fractal dust. But no single natural theory fit all the data. It was into this debate that Harvard's Avi Loeb stepped, arguing that Oumuamua's shape and acceleration were consistent with an artificial object, specifically an ultra-thin solar sail designed to ride the pressure of starlight. The idea caused a firestorm, but it cemented a critical precedent. When objects from other stars arrive, we shouldn't assume they'll play by our rules. Oumuamua prepared the scientific world to ask bolder questions. Ancient sky metal. Humanity's fascination with metals that fall from the sky is not new, it's ancient. Over 5,000 years ago in ancient Egypt, craftsmen hammered tiny beads from a mysterious iron that they didn't mine from the earth. Modern analysis of these beads from the Giza cemetery reveals a nickel content of nearly 30%, far higher than any terrestrial ore. This was the unmistakable signature of meteoritic iron. The story gets even more incredible with the dagger found in the tomb of King Tutankhamun. Discovered in 1925, the pristine iron blade was a mystery for decades. Finally, X-ray analysis confirmed its celestial origin. The blade contained 11% nickel and traces of cobalt, a composition that matched iron meteorites. The Egyptians even had a name for this divine material, iron of the sky. It was rarer and more valuable than gold, reserved for pharaohs. This history matters because it establishes a fundamental contrast. Terrestrial iron ores almost never exceed 4% nickel. Meteoritic iron, however, is rich in it. The same questions our ancestors faced, what is this strange metal and where did it come from, are echoing today as we analyze the impossible alloys of 3I Atlas. Kilonova formation theory. So if not aliens, what could possibly create pure nickel vapor in space? The answer might lie in one of the most violent events in the universe, a kilonova. This is what happens when two neutron stars, the ultra-dense corpses of massive stars, spiral into each other and collide. The resulting explosion is so powerful, it forges heavy elements through a process of rapid neutron capture known as the R process. In 2017, the gravitational wave event GW170817 gave astronomers their first direct look at this process, confirming that neutron-star mergers create vast quantities of heavy elements like strontium, gold, and platinum. Nickel is also created in this cosmic furnace. Crucially, depending on the chaotic conditions of the explosion, some models predict that patches of the ejected debris can be exceptionally rich in nickel while being poor in iron. These aren't the slow-cooked metals from normal stars. They are forged in seconds and blasted into space. If 3I Atlas condensed from such a cloud of debris, it would carry a chemical fingerprint completely alien to our solar system. This provides a natural, albeit spectacular explanation for its strange composition. Asymmetric supernova theory. So, there's another natural forge out there in the cosmos, violent enough to potentially explain 3I Atlas's strange chemistry, an asymmetric supernova. You see, not all stars meet their end in neat spherical explosions. Some, well, they rip themselves apart in these lopsided blasts that fling elements out in jets. The supernova remnant W49b is a perfect example of this. X-ray maps from the Chandra Observatory show that iron is packed tightly near the remnant's core, while other elements like sulfur and silicon are distributed more broadly. This kind of uneven explosion, it completely changes the rules of how metals are scattered into space. In these chaotic events, the inner layers of the star, where iron and nickel are made, don't mix evenly. Instead, high-speed plumes can punch through the star's outer layers, carrying specific elements with them. And if nickel happens to be concentrated in the path of one of these jets, it can be ejected in bulk, leaving most of the iron trapped behind. So, if 3I Atlas formed from a fragment blasted out by such a supernova, it could have started its journey as a chunk of nearly pure nickel. This provides a second plausible, though very rare, natural path to its bizarre composition. Statistical improbability. Beyond its strange chemistry, the path of 3I Atlas through our solar system is so unusual it's hard to ignore. Avi Loeb and his collaborators ran the numbers, calculating the probability that a random interstellar object would have a trajectory that takes it unusually close to Venus, Mars, and Jupiter, all in a single pass. The result was a probability so small it's almost zero, about 0.005%. That's like flipping a coin 15 times and getting heads every single time. To Loeb, this really strains the definition of coincidence and starts to look like a pattern. The object's path is nearly flat relative to the solar system's plane, but it's moving backward or retrograde against the flow of the planets. This combination allows it to skim past the inner worlds in a way that looks suspiciously like a survey flight. Critics argue that in a vast universe, rare events are bound to happen, but Loeb counters that if the odds are 1 in 20,000, and we've only seen 3 interstellar visitors so far, something doesn't add up. When you combine this improbable trajectory with the engineered-looking metals, Loeb argues it's time to take the artificial origin hypothesis seriously. The Golden Record Parallel. Could 3I Atlas be a message in a bottle? In 1977, NASA launched the Voyager 1 and 2 spacecraft, each carrying a golden record. This was a project led by Carl Sagan, intended as a time capsule for any extraterrestrial civilization that might find it thousands of years from now. The records contain sounds and images of Earth, music from various cultures and scientific diagrams, a snapshot of humanity etched onto a durable physical object. Sagan said, "The launching of this bottle into the cosmic ocean says something very hopeful about life on this planet." Now consider 3I Atlas, an object loaded with alloys and compounds that don't fit natural recipes on a trajectory that seems too precise. The parallel is striking. What if its message isn't written in grooves on a record, but in the very ratios of its elements? A physical archive designed to survive a journey of millions of years. If its composition is intentional, then 3I Atlas isn't just a visitor. It's a courier carrying a record of another world's chemistry, and maybe even its technology. Atomic messages. What if we've been looking for the wrong kind of message? For decades, the search for extraterrestrial intelligence has focused on radio waves and light signals. But what if an advanced civilization chose to send a message encoded in matter itself? This is the provocative idea that the anomalies of 3I Atlas force us to consider. On Earth, scientists are already developing methods to store information using the ratios of isotopes in molecules, creating a kind of atomic fingerprint that can be read with a mass spectrometer. In biology, DNA stores vast amounts of information in a sequence of 4 chemical bases. Some theorists now wonder if the periodic table itself could be used as a sort of cosmic QR code. By arranging isotopes in a pattern that nature would never produce by chance, a message could be baked into a physical object. This message would be incredibly durable, immune to cosmic noise, and capable of surviving for billions of years. Spectrographs are now re-examining every bit of data from 3I Atlas, looking for these hidden patterns. The hunt is on for a fingerprint that says someone was here and they wanted to be found. The story of 3I Atlas leaves us at a profound crossroads. On one hand, we may be witnessing an undiscovered violent natural process, a kilonova or an asymmetric supernova capable of creating alloys we once thought impossible. On the other hand, the combination of inexplicable metals, extreme chemistry, and a statistically improbable trajectory has forced serious scientists like Avi Loeb to consider an engineered origin. This isn't just a theoretical debate, it's a real object with real data that is breaking our models of the universe. Either way, our understanding has to expand. Don't forget to like, subscribe, and hit the bell icon for more deep dives into cosmic mysteries. Thanks for watching Space Facts. What if I told you the greatest journey in human history is about to get a sequel? For nearly 50 years, 2 probes, relics of the 1970s, have been our only eyes and ears in the vast dark ocean between the stars. But their time is running out. Now scientists are designing a successor, a true interstellar explorer built for the 21st century, powered by next-generation systems and guided by artificial intelligence. This is the story of humanity's next great leap into the cosmos, so let's explore this together. The original Voyager achievement. Ever wonder what raw discovery looks like? Picture this. It's 1977 and NASA launches 2 spacecraft, Voyager 2 on August 20th and Voyager 1 on September 5th. Their mission, led by longtime project scientist Ed Stone, was to exploit a planetary alignment so rare it only occurs once every 175 years. This grand tour would use gravity assists to slingshot from one gas giant to the next. What they sent back from their 23-watt transmitters, about the power of a refrigerator light bulb, redefined our universe. At Jupiter, they discovered the first active volcanoes beyond Earth on its moon Io and faint rings around the planet itself. At Saturn, they mapped thousands of intricate ringlets and flew by the haze-shrouded moon Titan. But Voyager 2 kept going, becoming the only spacecraft to ever visit the ice giants. At Uranus, it discovered 11 new moons and 2 new rings. At Neptune, it found 6 new moons and powerful 1,200-mile-per-hour winds. These weren't just flybys. They were foundational moments in planetary science, transforming our understanding of the outer solar system from distant points of light into complex, dynamic worlds. A journey into interstellar space. So what happens after you complete a grand tour of the outer planets? You keep going, farther and faster into the unknown. After their primary missions ended in 1989, the Voyagers began the Voyager Interstellar mission. Their new objective was to reach the edge of the heliosphere, the vast magnetic bubble inflated by our sun's solar wind that shields the planets from about 75% of galactic radiation. For years they traveled toward this boundary. Then on August 25, 2012, Voyager 1 made history at a distance of 121 astronomical units, or 121 times the distance from Earth to the Sun. It crossed the heliopause, the final frontier of our solar system, and entered interstellar space. Stamatios Tom Crimigis, a lead investigator, confirmed the data was undeniable. Voyager 2, on a different trajectory, followed suit on November 5, 2018, at about 119 AU. Now, Voyager 1 is over 163 AU away, the most distant human-made object in existence. For the first time, we were getting direct measurements of the interstellar medium, data sent from a place no probe was ever truly built to explore. Current limitations of the Voyagers. Here's the hard truth. The Voyagers are technological miracles, but they are also antiques from the dawn of the digital age. We're talking about spacecraft with a total of 69.63 kilobytes of computer memory, trying to send signals that take over 22 hours to reach Earth. Their data transmission rate is a painfully slow 160 bits per second, a speed that would make dial-up internet feel futuristic. Their instruments were state-of-the-art for the 1970s, but they were designed for planetary encounters, not the subtle environment of interstellar space. The biggest problem, as current project manager Suzanne Dodd often highlights, is power. The 3 radioisotope thermoelectric generators on each probe initially produced 470 watts of electrical power. Today that has decayed to under 250 watts and continues to drop by about 4 watts per year. To conserve every last drop of energy, the cameras were shut off in 1990 after taking the famous pale blue dot photo. Every year, more systems are powered down. Sometime around 2025 there simply won't be enough power to run any of the science instruments at all, and their historic journey will fall silent. The case for Voyager 3. With the original Voyagers fading, the question isn't just about continuing their legacy, it's about launching a revolution in interstellar science. The scientific community, including visionaries like Ralph McNutt Jr. from the Johns Hopkins Applied Physics Laboratory, isn't talking about a simple sequel. They're actually proposing a dedicated interstellar probe. This concept, which is often nicknamed Voyager 3, would be a machine designed from the ground up for a 50-year mission to explore the interstellar medium. It would carry a suite of modern instruments specifically built to analyze the space between stars with a precision the Voyagers could only dream of. The goal is ambitious: to travel 1,000 astronomical units from the Sun, more than 6 times farther than Voyager 1 has traveled in nearly 5 decades. This isn't about nostalgia for the Voyager name, it's about a critical scientific imperative. The Voyagers proved we could touch the stars, but they left us with more questions than answers. A new probe would be our tool to finally understand our place in the cosmic neighborhood. Advanced technology capabilities. So, how do you build a spacecraft for a 50-year journey to the stars? Well, you start with radical speed. A modern interstellar probe, as conceptualized by Ralph McNutt's team at APL, would need to travel much faster than the Voyagers. The plan involves a daring solar obirth maneuver. The spacecraft would dive incredibly close to the Sun, within 4 solar radii of its surface, where it would be subjected to immense heat and radiation. At its closest point, it would fire its engine, using the Sun's immense gravity as a slingshot to accelerate to speeds approaching 95 kilometers per second. That's about 20 astronomical units per year, nearly 3 times faster than Voyager 1's current velocity of 17 kilometers per second. This would allow it to reach the heliopause in just 15 years. To survive this maneuver, it would require a revolutionary new heat shield made of carbon-carbon composite. On board, AI-powered systems would handle navigation and fault management, making autonomous decisions light hours away from home. Power would come from next-generation nuclear systems designed for a 50-year-plus operational life, ensuring it could send back a robust stream of high-resolution data for decades. The interstellar medium mystery. Why is it so critical to study the space between the stars? Because our solar system is not an island, it's a ship sailing through the interstellar medium, and the heliosphere is our hull. For years we thought this protective bubble was shaped like a comet, with a long tail stretching behind it. But the data from the Voyagers, combined with models from astrophysicists like Merav Ofer of Boston University, suggests something far stranger. Her models indicate the heliosphere might be a deflated croissant or have 2 distinct jets, a shape no one predicted. The truth is, we don't know for sure because we only have 2 data points from the Voyagers. A dedicated interstellar probe with modern plasma and magnetic field sensors could finally map its true structure. It would directly measure the density of the local interstellar cloud our Sun is passing through, about 0.1 atoms per cubic centimeter, and chart the strength of the interstellar magnetic field. Understanding this interaction is fundamental to knowing our place in the galaxy and the nature of astrospheres around other stars. Scientific objectives and research goals. So, what specific questions would a new interstellar probe answer? Well, let's get into the hard science here. The primary goal, as laid out in the Interstellar Probe Concept Study, is to understand the heliosphere as a habitable astrosphere. By directly sampling the pristine material of the local interstellar cloud, it could actually determine the true composition and state of the galactic medium our solar system formed in. Second, it would map the magnetic field structure from the Sun all the way out into the galaxy, revealing how our local magnetic bubble gives way to the vast magnetic field of the Milky Way. This is critical for understanding how cosmic rays are filtered and accelerated. Third, from a vantage point hundreds of astronomical units away, it would be able to look back and image our entire solar system as a single system. It could observe the zodiacal dust cloud, the dust left over from the formation of our planets, and see how it glows, providing a vital ground truth for what telescopes like JWST are trying to observe around distant exoplanetary systems. All in all, it would bridge the gap between our home and the billions of other star systems in the galaxy. Practical applications for future missions. This isn't just about pure science, it's about laying the foundation for humanity's future in space. A modern interstellar probe would be a crucial pathfinder, charting the hazards of deep space. Its most important practical application would be creating the first detailed map of the radiation environment beyond our heliosphere. We know from Voyager data that the flux of high-energy galactic cosmic rays is roughly 3 times higher outside the heliosphere. These particles can damage electronics and pose a significant threat to biological life. A new probe would measure this radiation with unprecedented accuracy, providing the essential data engineers need to design shielding for future robotic and eventually, human interstellar missions. Understanding the plasma turbulence and magnetic field orientation is also critical for developing safe navigation strategies. Just as early sailors needed charts of ocean currents and reefs, future interstellar explorers will need a map of the interstellar medium. This mission would create that first map, making the next steps in exploration possible. Cultural significance and golden record 2.0. Beyond the science, there's the story of us. The original Voyagers carry the golden records, 12-inch gold-plated copper discs conceived by a team led by Carl Sagan, Ann Druyan, and Frank Drake. They are time capsules carrying 116 images and 90 minutes of sounds and music from Earth, from Bach to Chuck Berry. They are a message in a bottle thrown into the cosmic ocean. A new interstellar probe would carry this tradition into the 21st century. Imagine a golden record 2.0, not an analog disc but a digital archive with terabytes of storage. It could contain the entirety of human knowledge, our science, our art, our music, our languages. It could carry a message crafted not just by a small committee but by humanity itself, perhaps even using AI to create a message designed to be universally decipherable. It would be a dynamic reflection of who we are now, a global, interconnected, and complex species. This probe would be both a scientific instrument and a cultural ambassador, carrying the story of a curious species from a small blue dot into the vastness of the galaxy for eons to come. Timing and opportunity. Here's why this conversation is happening right now. The original Voyager's Grand Tour was a once-in-a-lifetime opportunity. To achieve the immense speeds needed for a true interstellar mission in a reasonable time frame, we need a similar advantage. As identified by Ralph McNutt and the APL team, a powerful launch window opens in the 2030s. A launch in 2036, using a powerful rocket and a Jupiter gravity assist, would provide the optimal trajectory to reach the target speed of 20 astronomical units per year. Missing this window would mean waiting until the next alignment in the late 2040s, a significant delay for a mission that is already decades in the making. The technology needed for the core mission is largely ready or in advanced development. This isn't a far-off dream, it's an achievable plan with a clear timeline. The Voyagers have been our scouts, but their journey is nearing its end. If we want to build on their legacy rather than letting it fade into silence, the time to commit is now. The cosmos is waiting, and the launch window is opening. From the revolutionary discoveries of the original Grand Tour to the tantalizing mysteries of interstellar space, the Voyager legacy has pushed the boundaries of human knowledge. Now, with concepts like the interstellar probe, we have the chance not just to continue that journey but to begin a new, bolder era of exploration. It would be a mission to understand our home in the galaxy, to test the limits of our technology, and to carry our story to the stars. The first Voyagers were our messengers to the cosmos. This next one could be our guide. Are we ready? Don't forget to like, subscribe, and hit the bell icon. Thanks for watching Space Facts. So, what if the most terrifying message from the stars wasn't actually a broadcast, but an object? And what if that object wasn't just, passing through, but actually reporting back to something else out there? In 2025, officials confirmed the detection of our solar system's third interstellar visitor, an object they called 3I Atlas. But as they decoded its transmissions and analyzed its totally impossible flight path, they confirmed a fear that humanity has honestly held for centuries. This wasn't just some random rock, it was a messenger. So, let's explore this together. The impossible visitor. So what happens when a visitor from another star system doesn't just tumble through, but actually navigates? When the Vera C. Rubin Observatory in Chile first flagged 3I Atlas in early 2025, it immediately defied every known classification. Unlike our previous interstellar guests, this object showed something that, sent a chill through every Mission Control Center controlled flight patterns. Dr. Karen Meach, a University of Hawaii astronomer famous for her work on Oumuamua, was among the first to point out that its trajectory was, quote, non-ballistic to a degree that is simply not natural. It executed deliberate, impossibly precise course corrections. Its sheer scale was staggering. It was surrounded by this massive 700,000-kilometer coma, a glowing envelope of gas and plasma nearly half the diameter of our own sun. But unlike a comet's coma, this one didn't sublimate chaotically. It pulsed, beating like a cosmic heart with powerful electromagnetic signals at a frequency of 1.42 gigahertz. The hydrogen line, which is pretty famous in SETI circles, firing in a perfect rhythm, once every 147 seconds. As this impossible visitor carved its way through our asteroid belt with surgical precision, one chilling question began to emerge. What if this thing wasn't exploring, but was actively reporting back? When physics stopped making sense. Here's where the story honestly takes a sharp turn from scientific curiosity into a genuine threat. Most objects from beyond our solar system follow these chaotic trajectories, their paths just dictated by gravity. But 3I Atlas showed us something entirely different. Its path allowed it to drift past several planets in ways that maximized gravitational efficiency, a maneuver that reminded JPL engineers of those complex gravity assist routes they designed for probes like Voyager. When celestial mechanics experts like Jacques Lasker from the Paris Observatory ran the orbital simulations backward, they found something, statistically impossible without intelligent intervention. The path of 3I Atlas required navigating through dense meteoroid streams and planetary collision zones with a mathematical elegance that was honestly breathtaking. Its trajectory deviated from a purely gravitational path by a measured 0.05 arc-seconds per hour, a tiny but constant thrust that had no visible source. It moved like a grandmaster's chess piece on a cosmic board, avoiding every conceivable threat with a precision that suggested either advanced, long-term planning, or some kind of sophisticated real-time control. This wasn't just a random space rock wandering through the cosmos. It was, as some scientists began to describe it, exhibiting piloted behavior. The object that defied reality. The unsettling feeling that we were dealing with something far beyond our comprehension only got stronger when NASA, under the guidance of senior JWST scientists like Dr. Jane Rigby, pointed the James Webb Space Telescope toward 3I Atlas. The results that came back didn't just challenge our understanding, they totally rewrote the rulebook. The thermal readings showed a consistent, stable temperature of 120 Kelvin, with rhythmic heat emission patterns that pulsed in sync with its radio signals, a behavior that, honestly, just defies thermodynamics. Webb spectrography revealed materials never before seen, including hyper-reflective compounds that returned almost 99% of the light that hit them. But the most disturbing discovery was a faint, recurring electromagnetic anomaly echoing from within. This low-bandwidth frequency at 408 MHz repeated every 147 seconds, matching the exact signature of a known pulsar, PSRB 1919+21. The problem, as any physicist would tell you, was that the object had no spinning core and no magnetic field capable of generating such a signal. It looked like it was mimicking something it had encountered, or even worse, actively communicating with something beyond our detection capabilities. Two visitors, one terrifying pattern. The mystery deepened significantly when researchers cross-referenced the electromagnetic signature of 3Y Atlas with archived data from Oumuamua. The comparison revealed something that honestly sent shockwaves through the scientific community. The exact same 147-second frequency had been detected briefly in Oumuamua's data, a faint 3 sigma detection that was initially dismissed as noise. The crucial difference, though, was that 3I Atlas's signal was a powerful, sustained 50 sigma detection, an unmistakable beacon. This discovery, championed by controversial Harvard astronomer Avi Loeb, completely reframed our understanding of both objects. Oumuamua had puzzled scientists, but now a disturbing pattern emerged. The evidence suggested that Oumuamua may have been a reconnaissance probe. If this theory held merit, then 3I Atlas represented something far more significant, not passive observation but active engagement. It was, in effect, the difference between a single radar ping and a fully operational surveillance system. Some researchers now theorize that Oumuamua was the lock, and 3I Atlas is the key, designed not just to observe but to unlock something, whether buried on our planet or awaiting activation in orbit. When space objects make calculated decisions. Just when scientists believed they had mapped 3I Atlas's future trajectory, the object performed a maneuver that, honestly, shattered every remaining assumption. Telescopes in Chile and Hawaii recorded a subtle but unmistakable course shift that couldn't be explained by gravity or solar wind. The object veered slightly off its projected arc, executing a 15-meter-per-second delta V that realigned its vector, bringing it 1/10 of an astronomical unit closer to Earth's orbital plane. To mission analysts at NASA's Deep Space Network at JPL, the implications were, well, alarming. The timing and precision of this maneuver implied conscious decision-making. Even more intriguingly, the maneuver occurred precisely when the James Webb Space Telescope had achieved its optimal tracking position, suggesting the object was not only aware of our surveillance efforts, but was reacting to them. This transformed 3Y Atlas from an astronomical curiosity into a potential confirmation of technologies far beyond our own. It was no longer a passive object of study, it was an active participant in a cosmic dialogue we didn't know we were having, a dialogue that was now escalating. Ancient mathematics from the stars. As if its movements weren't enough, independent cryptographers at the SETI Institute, inspired by the lifelong work of pioneers like Dr. Jill Tarter, uncovered something extraordinary. Using Fourier analysis of the pulse's phase modulation, they found precise mathematical ratios hidden within the signal, the golden ratio, Fibonacci sequences, and the first 100 prime numbers encoded in binary. These weren't just arbitrary concepts, they represent fundamental codes that appear throughout the natural universe. The precision of these patterns suggested a level of mathematical sophistication far beyond random cosmic noise. Even more disturbing, though, was the dynamic nature of these signals. The mathematical patterns weren't constant, they changed subtly, reacting to solar activity and even our own radio emissions. Most chilling of all, researchers detected a brief disruption, a single skipped pulse, that matched exactly with the moment James Webb first locked onto it. The object appeared to know it was being observed, and had responded with a mathematical fingerprint that spoke a language older than human civilization itself. Organic chemistry from beyond the stars. So, James Webb's detailed spectroscopic analysis revealed another, disturbing layer to the 3I Atlas mystery. The telescope detected complex carbon molecules on the object's outer shell, specifically polycyclic aromatic hydrocarbons, which are, the building blocks of prebiotic chemistry. These compounds, as astrobiologists like Carl Sagan have long theorized, are the precursors to life itself. But what was really alarming was the purity and organization of these molecules. Unlike the chaotic mixtures found in comets, the compounds on 3Y Atlas showed 99.9% isotopic consistency, a level of molecular organization that just doesn't occur naturally in space. The spectral lines at 3.3 micrometers, a key signature of PAHs, were unnaturally sharp and clear. Some researchers, including those at MIT under the guidance of experts like Dr. Sarah Seeger, began to theorize that 3Y Atlas might represent a seed ship, an ancient vessel designed not just to explore but to plant the foundations of life on suitable worlds. If this theory held merit, then Earth's location along the object's trajectory might not be a coincidence at all. When Earth responded to the cosmic visitor. When Earth responded to the cosmic visitor, the connection between 3-1 Atlas and Earth became, well, far more unsettling. A classified high-altitude surveillance balloon, managed by the U.S. Antarctic program, detected something extraordinary. The balloon's instruments recorded a powerful microwave burst at 23.5 gigahertz, sharp and centered precisely above the South Pole. Now, at first, this was dismissed as interference, but its timing aligned perfectly with another angular shift in 3Y Atlas's trajectory. Moments after the burst, seismic stations that are part of the global seismographic network recorded ultra-low-frequency rumbles across the frozen continent. These deep, resonant frequencies were a perfect 0.0068 Hz, the exact inverse of the 147-second pulses being emitted by 3-1 Atlas. The synchronization was just impossible to dismiss as a coincidence. Somehow, this visitor appeared to be influencing activity on our own planet, possibly triggering responses from systems buried deep beneath the Antarctic ice. The object wasn't just passing by, it was actively interacting with Earth in ways that suggested a technological sophistication far beyond our current understanding. The Asteroid Belt Death Run. 3. I-Atlas is currently navigating through the main asteroid belt, a phase that presents honestly unprecedented risks. Unlike other objects, 3I Atlas cuts directly through the belt's core at a low 5-degree inclination, passing through a region with a particle density 50% higher than the belt's average. The object, moving at a blistering 42 kilometers per second, is surrounded by its massive 700,000-kilometer coma, creating unprecedented interactions with the billions of objects in the belt. Planetary scientists at institutions like the Southwest Research Institute are watching with bated breath. As 3Y Atlas moves through this environment with its powerful electromagnetic signature, it's creating disturbances never before observed. While a direct collision remains statistically low, its gravitational and electromagnetic effects could potentially alter the trajectories of other bodies in unpredictable ways, creating a cascading effect or, more concerningly, redirecting the object itself toward Earth's orbital path. This is a cosmic gamble with planetary consequences. Rewiring our solar system's neural network. Scientists have now discovered that 3Y Atlas's interaction extends far beyond simple gravitational effects. Its complex, dusty plasma envelope is actively interacting with the solar system's magnetic field, creating what researchers are calling an electromagnetic Webb effect. As 3Y Atlas cuts through the inner solar system, it could be generating packets of charged dust that flow along the sun's natural electric currents toward Earth, potentially triggering geomagnetic storms. But the most disturbing discovery is the most recent. Observations from the Allen Telescope Array show that 3Y Atlas has begun emitting a secondary signal, a lower frequency, longer pulse at 700 MHz, pointed directly toward the Orion constellation. As SETI astronomer Seth Shostak noted, a signal not pointed at us is infinitely more chilling. Some researchers believe it's calling for reinforcements. Others think it's reporting back on its findings, but either way, one conclusion seems undeniable. This was never just an interstellar rock. This was a node, a probe, a messenger, broadcasting to something else that is still on its way. The story of 3I Atlas is far from over. In fact, it may just be the beginning of a much larger, more terrifying story. The mounting evidence, the deliberate course corrections, the mathematical signals, the organic chemistry, and now a broadcast pointed toward deep space, all suggest that this object is not the main event. It is a precursor. It is an announcement that our solar system is no longer a quiet, isolated neighborhood. We may have just accidentally triggered a sequence of events that will fundamentally change humanity's place in the universe, and honestly, we are completely unprepared for what comes next. Thank you for watching Space Facts.